or 2. And this particular first question has to do with a right triangle and telling if something is a right triangle. What do we use, what formula or theorem do we use to test and see if something's a right triangle? You're in the right direction. Does anybody remember what it's called? It starts with a P? No. Pentagon's 5-sided figure. How's Pythagorean theorem? Everybody say it with me. Pythagorean theorem. All right, so I'm just going to write that up here so that you can see what it looks like. All right. I think having that little vacation last week messed us up, or the week before. Pythagorean theorem. And what the Pythagorean theorem says, we've been working on this the last couple of days as part of the homework review and so on, is leg squared plus leg squared is hypotenuse squared. Now, the hypotenuse in a diagram is always across from the right angle. We know how to draw that. We know how to draw the arrow. However, the thing that's a little bit tricky about the Pythagorean theorem and the hypotenuse is when we don't draw the diagram. What you have to remember is that the hypotenuse is always the longest side. Rachel, head in the game. Hypotenuse is always the longest side out of the 3. So that means 6 squared plus 8 squared equals 10 squared. If this checks, this is the very first thing we did with Pythagorean theorem. If this checks, it's true. It's a right triangle. And if it does not check, it's not a right triangle. What's 6 squared, everybody? 36. What's 8 squared? 64. And what's 10 squared? 100. What's 36 plus 64? So 100 equals 100. Check. Yes, it is a right triangle. Okay? Any questions on that? You should be able to do that. You even had one on your take-home test like that. Which, by the way, I think I'm going to get graded this weekend. Okay? I usually, you know how usually I have your test graded right away? Take-home tests are not like that because I have so many other things to do during the week that I don't have time during school to get them done. So on the weekends, if I have opportunities, which we're going to a dog show this weekend, so I expect to have some downtime in the evenings to get them graded. Okay. What is the image of the point 3, -4 after a dilation by a scale factor of -4? Key word here, dilation. What does dilation do? What operation? Add, subtract, multiply, divide. Multiply, good. So, what's 3 times 4? 12. And what's -4 times 4? -16. So my answer is 12, -16. The next question is, what is the image of 2, 5 after a reflection in the x-axis and the y-axis? So I'm going to go to 2, 5 right now. 2, 2, 4, 5. There's my point, 2, 5. Now, if I'm going to reflect over the x-axis, this is the word we talked a lot about in class yesterday. Reflection. Does anybody remember the 3 words you have to remember? Ethan. What are the 3 words you have to remember about a reflection? Something and something. Count and repeat. Very good. So this first it wants us to go over the x-axis. This is the x guy. 1, 2, 3, 4, 5. Then what do I do? 1, 2, 3, 4, 5. So 2, 5 becomes 2, -5. Notice the x part stayed the same. The 2 stayed the same. But the y parts did not stay the same. What happened to the y parts? Got negated. Very good. Now let's do the y-axis. This guy's the y-axis right here. Sometimes kids forget if you have the y-axis, you can just connect there and make a y. Can't do that over here. Ready? 1, 2. What do I do now? 1, 2. So what are the coordinates of that point? -2, +5. So that one would be -2, 5. And for the y-axis, the x gets negated, and the y stays the same. So whatever the axis is, it stays the same. The x stayed the same when I went over the x-axis. The y stayed the same when I went over the y-axis. Okay. In the space below, graph the line y equals 2/3 x plus 1. Okay, what's the slope? What's the y-intercept? Come on, that's how we graph lines. What's the slope? 2/3. What's the y-intercept? 1. So I begin, that's why we have a b for y-intercept. I begin at 1. Up 2/3. Up 2/3. Continue on the back side here. Here's my graph. Now, let's show you some similar triangles and dilations that might not be so obvious. Well, check it out. Ready? There's a right triangle. But now, using the same slope, look at this one. Now, don't dilations make things bigger by multiplying? You with me on that? Right? What operation do you use with dilations? Multiplying. Check it out. This green leg here is 3, and this one is 2. Now let's look at the blue legs. Now this was a dilation. I made it twice as big because look, I counted 2 dots. So this is 6, and this is 4. What's 3 times 2? And what's 2 times 2? 4. I could do another one out to here. And now I've gone 1, 2, how many times this big? 3 times this big. So what's 3 times 3? 9. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times this big. This was 2. What's 2 times 3? 1, 2, 3, 4, 5, 6. So we have this idea of similar triangles. The green triangle is similar to the blue triangle, is similar to the black triangle. Remember, similar means same shape, proportional sides. And I have proportional sides here. Look at these sides. In each case, they all break down to the same thing. 2/3 is equal to 4/6, which is equal to 6/9. That ratio is all the same. And that gets into this thing in trigonometry, which you start learning about when you're in 10th and 11th grade. Okay. Now, we talked yesterday about finding symmetry on a graph. This is what I want you guys to do. Talk to a person sitting around you. Work together on this. I want you to draw this triangle, ABC, on your coordinate paper. Then, after you graph the triangle, we're going to reflect it over first the y-axis, and then we're going to reflect the result over the x-axis. Work together. I'll give you about, I'd say maybe 3 or 4 minutes to get that done. Then I'll come up and put that on the board for you. Begin. Draw that, reflect it over the x-axis, reflect it over the y-axis. You do realize I'm giving you permission to work with people around you. You don't have to sit there silently. About another minute or so, maybe 90 seconds. Pushing up. Okay, ready? It says first to reflect over the y-axis. What three words do you remember every single time you talk about reflection? Count and repeat. Ready? 1, 1. How come I didn't go down?
Because you're reflecting over the y.
Right, exactly. This is the y-axis. The other one will be the x-axis. 1, 2, 3, 1, 2, 3. And then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. B prime, C prime, A prime. And doesn't it just look like I could fold over the y-axis and the red one and the black one will land on top of each other? Excellent. Okay. And then it wants us to write the coordinates. A prime would be positive 1, 2. B prime would be positive 3, 5. See how the y's are getting negated? Or the x's, I'm sorry, are getting negated? And then negative 5, 4 becomes positive 5, 4. All right, now the next thing it wants us to do, now it says write the rule. So in general, xy becomes what? Which one gets negated? The x. So the, negative x, y. Okay, the x guy gets negated. Okay, write the coordinates, we did that, and then it says the result when the original one is reflected over the x-axis. So I'm going to reflect over the x-axis. What three words do I remember? Count and repeat. 1, 2, 1, 2. There's A double prime. 1, 2, 3, 1, 2 is 5. 1, 2, 3, 1, 2. There we go. B double prime. C. 1, 2, 3, 4. 1, 2, 3, 4. C double prime. You see how that looks like the black one flipped over the x-axis. Now, what would happen for this little r means reflection? You watching? Little r means reflection over the x-axis of xy. The general rule would be what? xy would become what? What gets negated, the x or the y when I flip over the x-axis? The y, right? The y is going from positive 2 to negative 2, positive 5 to negative 5. So the y is getting negated, and the x ends up staying the same. Questions? Preguntas? Okay. What is the result? Or I should say, what's the phrase you have to remember whenever you do a reflection? Count and repeat. Okay. Now, there's one other thing we didn't quite get to yesterday that I just want to mention very quickly. File, open recent. File, open recent. I want chapter 6, lesson 7. Now, if I scroll through here we go. Which of these choices looks like a reflection? Samantha? B. Doesn't it look like if you fold it over the line, it lands on top of itself? This is a type called a rotation. It's a twist or a turn. We will do those tomorrow. And this is called a translation. We will do those Friday and Monday. Okay?